So we're doing 7-3. It's called Piecewise Functions. Now it literally is exactly how the wording is of the name of the lesson. Piecewise functions literally means we're going to take functions and graph pieces of them. Just half of them or just some of them. Does that make sense? We're just going to graph pieces of the function. Now we spent the last 2 lessons remembering how to graph shifted absolute value functions, shifted quadratics, right? Square root functions we learned in one lesson, cube root functions, cubic functions, and so on. We know how to graph really well, correct? Now we're just going to go back to graphing, and we're going to be graphing pieces of functions on the same graph. So look right here. It says we have a function, and see this little squiggly means we have a group of functions. So this is function number 1, and this is function number 2. We're literally just going to graph these functions on the same XY chart. So watch, everybody look, this is a line, 2x minus 1. I'm just going to focus on the first function, y is equal to 2x minus 1. You do have to remember how to graph appropriately. So our y-intercept is -1, and our slope is 2. Remember, slope is rise over run, right? So my y-intercept, watch, I go down 1. This is not on your homework, and my slope is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Now look, I'm going to graph that line. Now I have right now the whole line graphed, but instead I only want to graph a piece of that. We're going to keep that function for any x value that is less than or equal to 1. So everybody look what I do. I go over to x equals 1. Isn't my function starting right here at x equals 1? We're keeping it for all x values below 1, which would be 0, -1, -2. Does everybody see? We're only going to keep the function for x values below 1. So I erase above, and there's the piece of the function I want to graph. Everybody see? There's the function for any x values below 1. Now I can completely ignore that. I'm just ignoring that, and I'm going to graph this function now. So my y-intercept, it's a line again. My y-intercept is 1. My slope is 3 over 1. So I'm ignoring this red line. I'm going to do a y-intercept of 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. So somewhere over here, right? And I could do the dots down here, but I'm seeing that I'm only graphing that for x values above 1. So I know it's not going to come down here essentially in the end. Does everybody see? So I'm going to just start here and draw that in. But now we're only keeping that for x values above 1. So watch what I do. I go over to 1, locate my function. Does everybody see what's right here? Only keeping it above 1, like 2, 3. So I've got to erase below 1, x equals 1. Now, did it include 1? No. So at, I go over to 1, go up to the function, and it has to have an open circle there to not include it. Now look, your graphs will make sense. They will be functions. So this, we would have known we've done it wrong if something weird happened like this. Like let's say that we would have graphed it and then we had this graphed instead, for example. You see how it does not pass the vertical line test? It's like double dipping. It's hitting both functions at the same time. You graphed it wrong. That's not going to happen. That is not a function. But look, our graph looks good because it's a function. Now look, for every x, there's only one y. In fact, when we get to x equals 1, our function's at 1, right? This one doesn't, it's an open circle, so it's not double dipping, and then it continues onward for x. Does everybody see how it passes the vertical line test? Is that hard? Not bad, right? Okay, cool. Let's do another one. So everybody just watching. So we would graph this. It says, graph this piece, x squared minus 1. So you will have to remember, quadratics shift left and right and up and down, right? This is a shift of down 1, isn't it? So I would start at the origin, go down 1. Then literally, just go to your calculator. Remember, this is what I allowed you to do. You would type in y equals, type in x squared minus 1, go to your table of values, and plot points to graph this. So type that in, y equals, give me some points. What's 2 at? 3. -2 is at 3. What's 3 at? 8. Cool. And then -3 is at 8. So look, I have my quadratic graph. Does everybody see? But now we're only keeping that for x values less than or equal to 2. So watch what I do. I go over to x equals 2 and I locate my function, kind of making it big and obvious that that's where I'm going to start. we're keeping it for x values below 2. Wouldn't that be like 1, 0, and so on? So I've got to erase above. Now, did it include 2? Yes, so it's a closed circle there. We're good to go. Now, moving on. I'm going to graph this line. So I'd say, okay, my y-intercept is 1. My slope is 4 over 1. So I'm going to go like this. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. And I could do it down here. And I'm going to connect it. Is everybody seeing? Now we're keeping it for x values greater than 2. So look, I go over to 2 and I locate where my function is. Isn't it like clear up here? Okay, so I'm going to make it big. We're keeping it for x values above 2. So I've got to erase below it. Everybody look. Now it's kind of off the graph, which is ugly, but that won't happen. Okay, so now greater than 2, but not including 2. So I've got to go over to 2, find the function, and open up the circle. Does that make sense? Now look, does it pass the vertical line test? Yes, because then look, at 2, it's a closed circle, open circle, and it continues onward. Everybody good with that? Okay, in the last 3 minutes, this is the easy part. Look how cool this is. So now it's asking us, what's my function at 0? At x equals 0, what's your function at? So look, you can use the graph. Go over 0, where's your function at? It's equal to -1. Now let me show you another way to think about it, because you're not always going to have the picture of the graph. It says, this is our function for any x value that is less than or equal to 2. Is 0 less than or equal to 2? Yeah, so we would plug it in right here. Now, is 0 greater than 2? No, so we would not plug it in here. We would only plug it in here. Look, 0 squared minus 1 is -1, so it does work out. Okay, let's do this one. What's my function when I plug in 2? We could look at the graph, look over 2, what's the function at? 3. Or we could just use the equation. So look, where should I plug it in? 2? Is it equal to 2? So I'd be plugging it in here. 2 squared is 4. 4 minus 1 is 3. Okay. Now it says, what's my function at 4? Now look, over 4, I don't know, it's somewhere up here, right? So instead, let's use the equation. Is 4 greater than 2? So I would plug it in right here. 4 times 4 is 16 plus 1 is, it would hit up at 17. Does that make sense? Okay, awesome. Okay, let's do this one as quick. Well, the bell is going to ring in 2 minutes, so let's just go to lunch a little early. So now we don't want to have to graph it unless it tells us to, so we just have to understand how it works. So just look at this example. We have 3 pieces to the function, piece 1, piece 2, piece 3. Now this is the function for x values between -5 and -1. Now think about what that would be. -5, -4, -3, -2. Does everybody see? All the values between those two. And then this is our function for values between -1 and 3, which would be -1, 0, 1, 2, 3. Does everybody see? And then x value is greater than 3. So it says find the function when x equals -4, when we plug in -4. Where does that fall? Yeah, the x plus 1. So -4 plus 1 is -3. Our answer would be -3. Okay, function when we plug in x equals 0. Where does that fall? In the middle. 0 minus 1. -1. When's the function when we plug in 3? Won't it still go in the middle one? Equal to? So 3 minus 1 is 2. And then what's the function when we plug in x equals 18? Won't that go down here? Because that's greater than 3. 18 times 2 is 36. Okay, do problem number 1 on the worksheet. So just watch. I'm going to do a couple examples, then we'll do one off your worksheet, then I'll let you go for it. So we're back to graphing these again. So now, so it says graph x squared plus 1 for x values less than 2, actually. So first of all, just focus in sections. It's like, once you look at the whole picture, you kind of go, well, I don't know where to start. Literally, all you do is graph x squared plus 1. You would say this is a quadratic that's shifted up 1, correct? You start at the origin up 1. Then plug in x, plug it into your y equals, or just calculate values. Plug in 1. What's 1 squared plus 1? 2. Plug in -1. You get 2. Do you guys see what I'm doing? Plug in 2. Yeah, so yep, it's a u, because yep, it's a squared. Good. And then if we plug in 2, 2 squared is 4 plus 1 is 5. Or you could type it into y equals. Type in. Don't try to memorize anything. I just want you to type it in your calculator and plot points. So yeah, so now look, I'm going to graph that. Now we're keeping that for x values less than 2. So watch, I go over to 2. Go find the function. We're keeping that below 2. So I'm going to erase above, right? Is it we're equal to 2? No, so I need to, yep, good point. I need to make that actually open there. Okay, perfect. Any questions? Yes. If it was between, we're going to get an example. Okay. And then right here, we have the square root of x. So we know there's no shift left and right, no shift up and down, right? So we start at 0, 0. Plug in, what's the square root of 1? 1. Now look, think. Square root of 2 is a decimal. I'm not going to plot decimals. I'd rather plot only whole numbers. Square root of 3 is a decimal. Square root of 4 is 2. Square root of 5 is a decimal. 6, 7, 8 is a decimal. Square root of 9 is 3. So I'm going to graph that. Now we're only keeping that for x values greater than or equal to 2. So watch what I do. I go over to 2 and locate where my function's at. It's right there. Kind of in a weird spot. I'm going to kind of make myself a little dot right there. Okay, we're keeping it for x values above that. So I'm going to erase the below part. And then is it and equal to 2? So we'll keep that closed. Now check if your vertical line test is passed. Yep, open circle, closed circle, good to go. And there's no double dipping. Okay, one more, watch very carefully. We're going quick. I promise you're going to be able to get that front page done. So this is a parabola that's shifted up 4, isn't it? Everyone? So I'm going to go up 4. It's then reflected over the x-axis. But once again, from here, just type it into your calculator plot points. So if you plug in 1, you would just type, I would rather you just type it into your calculator and get it right. So everybody just quickly do that. You plug in 1, what do you get? Tell me, I already know, but you guys do it. You plug in 2, what do we get? If we plug in 3, we get negative 5. So you're just kind of watching me. I'm almost there. So I can graph this now, which makes sense, my upside down U. Now we're only keeping that for x values greater than or equal to 0. So look, I locate 0. We're keeping it this side, right? X value is greater than 0. So watch, because this is interesting. Something happens different here that you have not seen before. Is everybody good from there? Okay. Now I'm going to graph this absolute value functions. I don't know. A few people second hour had a hard time graphing these. These are the V's, aren't they? This is shifted up 4. So we literally go up 4, put a dot right there. Then isn't this a slope on a V? 1. So watch it. What? Up 1 over 1. Up 1 over 1. And then I have my V, but now we're only keeping it for x values below 0. So we're only keeping this side. Now here's what's interesting. Isn't that an open circle one right there? Well, that's an open circle on top of a closed circle. The circles are the same size, so it just closes off the circle. There was an open circle and a closed circle. It just closes it off. Does that make sense, everybody? So look at it. It matches the vertical. It passes the vertical line test, and there's no double dipping. All good? Okay, go to number 3. Let's do number 3 together. So there's 3 functions here. The first function we're going to graph is x squared. Let's start plugging in points. There's no shift left and right, no shift up and down. So we're starting at 0, 0. Plug in 1, 1 squared is 1. Plug in negative 1, negative 1 squared is 1. So let's graph this. Plug in 2, you get 4, because 2 squared is 4. Negative 2 squared is 4. Plug in 3, 3 squared is 9. So you guys, you have to plot these exactly. So now draw in your parabola. We're only keeping that parabola for x values less than 1. So does everybody have their parabola drawn? Go to 1, go up to there, and kind of make yourself a little note. That's where I need to start. We're keeping it for x values below 1. So erase the above. Is that we're equal to 1? No. So at 1, we've got to open that circle. At x equals 1, we've got to open that circle. Make it so I can tell it's an open circle. Any questions before we move on to the next piece? This tends to throw people for a loop. negative 2. So I want to remind you, think of that as 0x minus 2, everybody. What's my y-intercept? Negative 2. What's the slope? 0. So it's like this since there's no slope. But we're only keeping that for values between 1 and 4. Does everybody see? So go and erase everything that's not between 1 and 4. So I'm going to erase up to 1, between 1 and 4. You see how that leaves it between 1 and 4? Okay, cool. Now let's see. Go to 1. It's including 1. So go over to 1, go down to your function and do a closed circle. We graphed this straight line and then erased it to be between 1 and 4 because that was our interval. Does that make sense? Okay, cool. And then right here, let's go over to 4. And then it's go down to your function. It's not including, so do a little open circle right there. And now moving on to the next function. I'll go ahead and change colors. So now we're going to have to ignore all that stuff and graph root x. So think about it. No shift left and right, no shift up and down. So we're starting at 0, 0. Just put a little dot there. Then plug in 1, you get 1. Square root of 1 is 1. But careful, because we might not be graphing, and that's an open circle, right? I'm going to put a little dot like kind of off on the side right there. Plug in 2, it's a decimal. 3, a decimal. 4. Yep, so go over 4 up 2. 5, 6, 7, 8 is a decimal, but the square root of 9 is 3. So go ahead and plot that. Now, if we were going to draw this, it would all connect like this. But we're only keeping that for x values greater than 4. So go to 4. That's where we're starting. Yeah, so I need you, just because otherwise that would be an open circle and an open circle, making it not a function. So that actually is a typo on my part. So if you would go ahead and add in a line down there, even though yours doesn't have it, that would be great. Good point. So now look, go over to 4. That's a closed circle. And then check, everything looks good here. Open circle, closed circle, open circle, closed circle. There's no double dipping. Does that make sense? Okay, cool. I want you to do 2 through 5 on the front. Graph those perfectly. Plot points. That's all you got to do. Think of how these work. Shifts left and right, shifts up and down. We know how to graph. Up here. This is not on the worksheet, but it will be tested on. There are 2 problems on the test where you're asked to go backwards, and it is harder. So watch. And it will be on the review. So just watch. You guys just pull yourself back up here, because if not, you're going to be lost. So you are going backwards. They're saying write the equation to this function. So you'd say I have 2 pieces. F of x is equal to, you write this little bracket because you have a group. So you have function number 1 and function number 2, correct? Now don't let it throw you off. We know how to write shifted functions, and we know how to write lines. Isn't this a line? Lines have the form mx plus b. What's my y-intercept? So we're going to have plus 3. Does everybody understand? What's my slope? Up 1 over 1, isn't it? And it's positive because it's an uphill line. So it would be 1x. So our first equation was x plus 3. Now when did they keep the function? For x values below 1, isn't it? Look, 1. So we're keeping the functions for x values less than 1. Is anyone confused? Not equal to 1 because it was an open circle. Now let's write the equation for number 2. Now here's what throws people off. You've got a picture in your head that this continues. It's just been erased. Isn't this just a quadratic? It's been shifted inwards, right? 1. Any shifts up and down? Nope. And then is there a stretch or a compression? Nope. Over 1 up 1. So isn't that this x minus 1 squared? Right? Because it's a parabola, yeah. So we would say x minus 1 squared. And isn't that for x values greater than or equal to 1? Yes. No, it's not, but it's going to be tested on and on the review, so we're just looking at this. Okay, let's look at one more that I'm going to have you try one by yourself. Stick with me. Now, looking at this function, there are 3 functions. Number 1, you see how it changes here? Number 2, number 3. Let's write this equation. So you say I have a group of functions. There's my group. The first function, you'd say it's a line. You have to picture it continuing in your head. If it continued, it would do a y, and lines have the form mx plus b. What would my y-intercept be? 0. So we'd have a plus 0. What's the slope? So we have this 0x plus 0, which happens to be 0. Aren't we having that for x values between -5 and -2? So watch how I do it. I put an x, I put a -5, and I put a 2. Now it's between that, so greater than, isn't it closed or equal to, less than or equal to, because isn't it closed? Okay, cool. Moving on to function number 2. Isn't this a quadratic again? In words, it was shifted up 4, no shift left and right. So wouldn't that be this? X squared plus 4? And then it's flipped upside down. And there's no stretch or compression because it's over 1, down 1. So just negative, right? So my second function is -x squared plus 4. And what x values is that between? -2 and? So I put an x, I put a -2, I put a 1. Less than, can I put an equal to, or have we, oh, I meant to put, oh, -2 here, didn't I? Up here? Okay, I meant to put -2. It was between -5 and -2. We already have an equal sign here, so we can't put an equal sign here. That'd be double dipping. But then, is this a closed circle at 1? So I do have to put or equal to 1. Okay, function number 3 is a line. You do have to picture it continuing in your head, because that has this form, mx plus b. So if it continued in the same fashion, it'd be up 1 over 1, up 1 over 1. It would be intersecting at 3. Why intersect? Or why intersect? What's my slope? Down 1 over 1, down 1 over 1. And isn't it going downwards? So -1x. So our last function is -x plus 3 for x values between 2 and 5. So you go x between, I didn't leave very much room, between 2 and 5. At 2, it's not equal to. At 5, it is equal to. Is everybody good? Try this one by yourself, okay? It is very important. 2 questions on the test is well worth your time of trying it by yourself. Ready, go. Write the equation C. Test yourself. Can you get these 2 questions correct on the test? So you should say this is shifted. Left 3 up 2. X plus 3. Opposite, then plus 2, right? Slope is 1. We're good to go for x values less than or equal to -1. Then this quadratic was shifted up 1, x squared plus 1 for x values above, greater than -1. Did you get it right? Awesome. Try another one. Just 1 is not enough to just get it right. Yeah, write the exercise. Hey, try this one. Now remember, lines have the form mx plus b, where b is the y-intercept and m is the slope. Slope is rise over run. Guys, mx plus b. What's the plus b? The y-intercept. So what should that be? What's our slope? Rise over run. How much did you rise up? And then over 2. So you have to do 1/2 x minus 1. And yes, it's a downward facing line. It's going downhill, so negative. So you should have -1/2 x minus 1 for x values, what? Less than 2. Then you would say, I went right 3 up, no wait, right 3 up 3. So wouldn't that be this? X minus 3 plus 3? Now, a lot of you missed this. The slope was -2 over 1, wasn't it? -2 for x values greater than or equal to 2. Does that make sense? Some of us are going to need more practice writing equations later in the year. Okay, so this is what you're going to do. On the back of the worksheet is just a review of graphing stuff we've already done. Remember, what work I require of you is to state the shift and then plot that 1 point from the shift and then just type it into your calculator and plot points. The back is just review. That's what's homework. Very easy. Graph it correctly and exactly. Basically, type it into your calculator.